Today we're going to talk about derivatives of inverse trig functions. And I've given you a cheat sheet with a chart, and these are the different ways you might see how you might see an inverse trig function. You might see it x is equal to the arc sine of y, or on your calculator they'll have x is equal to sine to the -1 of y. What that means is if I give you the ratio, can you give me the angle? That's what the inverse trig function does. Usually at this point I've been giving you the angle, you've been giving me the ratio. Like for example, cosine of 30 degrees is equal to root 3 over 2. If I give you arc sine of root 3 over 2, can you give me the angle of 30 degrees? That's what it does. It's a function on your calculator. If you've been given a ratio, it gives you the degree. And these are the rules, the derivative rules for each of your inverse trig functions. And so let me just kind of give you several examples so you know how to use these rules. Number 1, find the derivative of arc sine of x squared. I already have written the formula for derivative of arc sine of u, so let's first find what u is. And u is always going to be what is right after your arc sine, so I'm circling it in blue. So our u is equal to x squared. One of the things I need to find is up here, I need to find u prime. Well, that means I just take the derivative. So the derivative of x squared is 2x. And so I'm just going to use this little formula that I have up here and just fill in my u and my u prime. So the derivative of arc sine of x squared, u prime goes on top, so that'll be 2x divided by the square root of 1 minus u squared. And so if I was going to square x squared times x squared will be x to the 4th. And we are finished. Number 2, the derivative of the arc cotangent, of the square root of x. And again, I give you the little rule at the top where the derivative of arc cotangent is equal to negative u prime divided by 1 plus u squared. So again, I'm going to circle my u. It's going to appear right after my arc cotangent, and so u is equal to the square root of x. Well, let's go ahead and put that in power form. So that means that's x to the 1/2. Let's go ahead and find u squared. So that means x to the 1/2 squared. And when I distribute through, 2 times 1/2 is 1. And so I get x. And then finally, let's find u prime. So the derivative of x to the 1/2 is going to be 1/2 x to the -1/2. And so let's use these values to find our derivative of our arc cotangent. So this is going to be equal to negative u prime. So we're going to fill in that -1/2 x to the -1/2 divided by 1 plus, and then u squared we said was going to be x, so we're going to fill in our x. Number 3, let's find the derivative of 3 times arc secant of x divided by 2. And once again, I gave you the derivative arc secant of u. It's going to be u prime over the absolute value of u times the square root of u squared minus 1. So let's find each of those. So u, again, appears right after my arc secant. So u is equal to x divided by 2. U squared is going to be, we'll be squaring our x divided by 2. and that gives me x squared divided by 4. And then u prime is going to give me, well, my coefficient is a half, derivative of x is 1, so we get my u prime is equal to a half. My absolute value of u looks like the absolute value of x over 2. So please be careful, my coefficient is 3, and he just remains there. He just stays on the outside. So 3 times, and so let's go ahead and fill in our formula. So we have u prime, which is a half, over the absolute value of u, which is going to be x over 2, times the square root of u squared, which was x squared, over 4, and then we're going to subtract 1. Number 4, find h prime of t if h of t is equal to t squared times arctangent of t. And again, right next to it, I gave you the rule for the derivative of arctangent of u. And so let's go ahead and find out this arctangent part first. And so its derivative, if u is going to be right after that t, that's my u. So u is equal to t. That means u squared is t squared, and u prime is equal to 1. Now I have to be really careful here because I have the product rule. I have t squared, which is a quadratic, being multiplied by an inverse trig function. So I'm going to have the derivative of the first times the second. So h prime of t is equal to the derivative of the first, which is 2t, times the second, which is our arctangent of t. And we're going to add that to the first times the derivative of the second. So let's set up our derivative of the second. So we're going to have, for the derivative of arctangent is going to be u prime. So u prime is going to be, my derivative of my u is 1 over 1 plus u squared. Well, u squared is going to be t squared. And that is my derivative. Alright, last one. Find the instantaneous rate of change for f of x is equal to arc sine of x plus x times the square root of 1 minus x squared. I've already given you the arc sine, so let's go ahead and do that. So we're just kind of setting ourselves up so when we take our derivative, we're ready to go. U is equal to x, that's immediately right after arc sine. U squared is going to be x squared. U prime is going to be equal to 1. So we're kind of set up to be ready to take the derivative. I have to be careful because I have several things going on with this problem. So I have this arc sine that I need to deal with. I have a product rule. Here's my first. Here's my second. But my second is going to be a plain M&M chain rule. So hold on tight as we go through this. So I'm going to first rewrite everything that I have. So this is going to be equal to, so my arc sine of x plus my first, which is x, times my second, which I'm going to change, put it in power form. So we raise to the 1/2. And so now I'm ready to take my derivative. So f prime of x is going to be equal to, so derivative of our arc sine is u prime, which is 1 over the square root of 1 minus u squared, so this will be 1 minus x squared. We're going to add that, and then now we're going to deal with our product rule. So the derivative of the first times the second added to the first times the derivative of the second. So here's, I'm going to do the derivative of my shell, which is 1/2. So this is going to be times 1/2. And I'm going to use space down here, guys, because I ran out of room. So this is 1/2 times, and then we do, this is all raised to the negative 1/2, and our chocolate still remains 1 minus x squared. And then I need to multiply by the derivative of my chocolate, which is on the inside. So the derivative of 1 minus x squared will be negative 2x. And so these are all of our arc sine, arc tangent, arc cotangent, and etc. These are all of our inverse trig derivatives. I gave a chart for you, so if you look at the chart, I try to match them up, and so there's actually really just 3 formulas. And once again, the cosine, cotangent, and cosecant rule still applies. All the cos are negative. So if you just kind of look on just straight across, I actually have the same formula, and it's co version of it, the negative version, right next to it.